Hey, here we are at Trig day number 1. Unit circle stuff, definition of sine, cosine, a little bit of translations, and then some tangent involved as well. In these two examples you'll see here, the sine of pi over 3, it should be the y value in the unit circle at pi over 3, which would be root 3 over 2. Example number 2, this is a little bit different. It's asking for an angle measure. And this right here is asking for an angle in radians, somewhere in that interval from 0 to 2 pi. So anytime you see that negative or any sort of 1 over root 2, you should think some kind of 45. And the cosine is negative in the third and the fourth quadrant. So I'm thinking x would be, how about 3 pi over 4 in quadrant 3, and 5 pi over 4 in quadrant, whoa, this is quadrant 2, hey now, and quadrant 3. Alright, let's see what we remember and what we've forgotten about trig. Alright, what do you remember about trig? Well, I remember most of it. You might have forgotten some of it over the summer. We got our favorite Pythagorean theorem. Only applies to right triangles. Right? What else applies to right triangles? How about SOHCAHTOA? Hello, stylus work. SOHCAHTOA. Okay, let's think of stuff that applies to non-right triangles. How about law of sines? Law of sines, law of cosines. Boy, what else? How about the area of a non-right triangle? Area of a non-right triangle, you may or may not remember, is 1/2 AB sine of C. What is that? If you don't have a right triangle but you have an angle, let's say 31 degrees between two sides, 10 and 8. Let's call this side A, this side B, and this is angle C. You can find the area of that triangle. Let's see, what have you forgotten about trig? Well, probably a lot. You probably forgot that sine is an odd function. Oh, that was a big negative sign. How about this? The opposite of sine is the same as sine of negative theta. Right, that's an odd function. Why is it an odd function? Because, well, the sine function has origin symmetry. Therefore, the sine here of pi over 2, that equals 1. And the sine of negative pi over 2 equals negative 1. Therefore, as it says here, the sine of the opposite angle is going to have the opposite output as the other. Right, so I got a negative pi over 2 here, which means that this will be the opposite output as this one. So I get a negative 1. Gives me a positive 1. It's got origin symmetry. It's kind of like a rotation around the origin. Right, so all these points rotating about the origin will match up with one that has the opposite sign. Plenty of other trig stuff that I'm just not going to cover in this page. So let's get to it. Definition of x and y on a circle. Okay, so let's say we have a radius of r, right? Then cosine is x over r, sine is y over r, tangent is y over x. Okay, here's our angle theta. Okay, now if the radius is 1, then the cosine of theta equals x over 1. The sine of theta equals y over 1. And the tangent of theta equals y over x. Alright, some basic stuff there with right triangles in the unit circle. Alright, here's your unit circle. Be functional with that. I'm not sure why, but we didn't put any of the 45-degree angles in here. I have no idea why, but that's that. Alright, you got 1 over root 2, comma 1 over root 2. That's positive, positive, right? So over here, it'd be negative, positive, same values. Down here we'd have negative, negative. And over here we'd have positive, negative. Alright, hopefully you've seen this before, but all students take calculus. What that means is in quadrant 1, all functions, sine, cosine, and tangent, are positive. All are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Alright, so I might ask you a question like, where's the tangent negative? Well, tangent is positive in 1 and 3, so tangent is negative in 2 and 4. Alright, that would be tangent of theta is positive in 1 and 3, negative in 2 and 4. Alright, those are some good things to be aware of. Alright, so sine only. Here's sine of theta, right? So sine of theta in this case is what, 1/2? Sine of theta plus pi, well, pi is 180 degrees, so plus pi would put it right here. Alright, and honestly, I don't even care what that angle measure is, even though I know it's 210, or 7 pi over 6. But all that I want is the sine there. Well, the sine there is going to be the same as the sine in quadrant 1, except it's going to be negative. What if I take sine of theta minus pi? Well, sine of theta minus pi instead of sine of theta plus pi will get me to the same place. So again, negative 1/2. Of course, those two, that would be sine of 7 pi over 6, right, in the second part. In the third part, that would be sine of negative 5 pi over 6. Those are coterminal. They're just different direction to get there. Okay, so how about sine of pi minus theta? Well, go to pi and then subtract theta. So if I rotate to pi, and then I subtract theta, I'd end up there. Okay, so the sine is actually going to be the same there. Alright, so instead of sine of pi over 6, I'd have sine of 5 pi over 6. Okay, and sine of theta plus 2 pi, that's a full revolution. It's going to be in the exact same spot. Alright, so from here, 2 pi, it's going to get me back to the same spot. Sine will be the same. And sine of pi over 2 minus theta. Okay, so let's rotate pi over 2. Bad color choice here. And then subtract theta. Alright, that's just going to be this angle right here. And at that angle right there, I'm going to switch colors now, our sine and our cosine just flip. So we get root 3 over 2. Alright. I'm not really going to do much on this page because these are going to be very similar to what we just had, except the fact that our x values are going to be what we're looking at. So I'm going to pause the video and post all these answers. So there you have it. Pause the video. You can check your answers if you'd like. Alright, tangent. Tangent here is y over x. If I took 1/2 over root 3 over 2, 1/2 over root 3 over 2, those 2's, they go away. I get 1 over root 3. Okay, so I get 1 over root 3, which can be commonly, wow, stylus. 1 over root 3. Okay, that's division symbol, which you can also see as square root of 3 over 3. Okay, so here I got 1 over root 3 as my tangent value. Here I'm going to have the reciprocal of that because I'd just be flipping the x and the y's. So here I'd have root 3. Here I'd have 1. There's only 2 more values you actually have to remember. Y over x here is 0 over 1, which is 0. Y over x here is 1 over 0, which is undefined. So you're going to have undefined tangents here and here. You're going to have zeros at 0 and pi and anything coterminal. And then everything else is just going to repeat with some negatives potentially. Right? We said that Quadrants 1 and 3, we're going to have the same sign for tangent. And quadrants 2 and 4 would all be negative. That is a 3. Oh my gosh, come on, work for me. 1 over root 3. And so this would be negative 1. This would be negative 1 over root 3. This would be negative root 3. Alright, if you know your unit circle, Trig's going to be fun. That's it for day number 1 in the books. Peace.